As you can see, the function is here negative 2 over x, so x should not be equal to 0, which means we should not include 0. Let's put an open circle on 0. So except 0, we can choose all the other numbers. We can choose all the numbers left of 0, and you can choose all the numbers right of 0, except the 0. Now what is the domain of the given function? So domain of this given function would be, you can take from negative infinity to 0, and then union 0 to positive infinity. So this becomes the domain of the given function negative 2 over x. Ever wonder what values you are actually allowed to plug into a function? Today, we are diving into one of the most important and misunderstood ideas in math, the domain of a function. Whether you are solving equations, graphing curves, or just trying to survive algebra class, mastering domain is your secret weapon. Stick around. By the end of this video, you'll be finding domains like a pro and avoiding the biggest mistakes students make. Say we are finding domain of the function f of x equals 2x minus 3. What is the domain of this function? Remember, domain is set of all possible inputs for the function. Now, what all the possible inputs for this function? So whenever the function is of this type, the domain would be real numbers. So the domain of this function equals real numbers, which you can say as negative infinity to the positive infinity. So the domain of this function is set of real numbers, or we can write as negative infinity to the positive infinity. That's the domain. Say we have next question. Say we take the function f of x. Say the function is f of x equals, we take 3x cubed minus 5x squared plus 3x minus 5. Now the question is, what is the domain? So what all possible inputs for this function? Now you can see that this question also similar to question 1. So whenever the function of this type, again the domain would be domain of this function equals real numbers, which is from negative infinity to the positive infinity. So domain is set of real numbers. What if the function looks different? Say, let's take another example. Say the function is f of x equals, say if it is like a fraction, say f of x is 4 over 1 minus x. What is the domain of this function? Now, whenever the function is of this type, like a fraction, now let's see how you find domain of this. For example, say if here 4 divided by, for example, say we have 0. In the place of 1 minus x, let's take a 0. What is 4 divided by 0? What is the answer? It should be undefined, right? So division by 0 is not defined, or you can say undefined, which means there should not be 0 in the denominator. If there is 0 in the denominator, that becomes undefined. So now, looking at that, you can say that 1 minus x is the denominator, so that should not be 0. Okay, so now what we do is, we take this 1 minus x, and this should not be equal to 0. What happens if there is 0? The whole thing becomes undefined. That's why the denominator should not be 0. So 1 minus x should not be 0. If 1 minus x is not equal to 0, now I can add, or I can just subtract 1 on both sides, so that this cancel out. So I get here negative x not equal to negative 1. Now here I divide by negative 1 on both sides. So here I get positive x, right? So not equal to negative 1 divided by negative 1, that's positive 1. So I get here x not equal to 1. Okay, so x not equal to 1, let's draw a number line. Say we draw a number line like this, And now we choose the number. Say we take positive 1 here, and it says x not equal to 1, which means we take a open circle on 1, so we should not choose 1. Except 1, we can choose all the other numbers. Now what is the domain of this function? Let's write down the domain. So the domain would be, you can see that except 1, we can take all the numbers. So we write domain equals, so domain of this given function equals, so we start from negative infinity, right, to the 1. So negative infinity to 1 union, and we take 1 to positive infinity. So the answer is negative infinity comma 1 union 1 comma positive infinity. That's the domain of the given function. So which means we are not including 1 except 1, all the other real numbers or the inputs of this given function. So this becomes the domain of the given function. Let's take another example question. Let's find the domain of that function as well. Say the function is f of x equals, let's take another fraction. So let's take f of x equals negative 2 divided by x. Let's see what is the domain of this function. Again, whenever you have a function of this type, so there should not be 0 in the denominator, right? So again, we take x here, which is the denominator. This should not be 0, which means we write x should not equal to 0. Okay, so x not equal to 0. Let's draw that. Let's locate that on the number line. Say this is the number line. We take 0 here. So which means we should not take 0. So let's put the open circle here, which means we are not taking 0. Except 0, all the other real numbers become the domain of the given function. So let's write down the domain of the given function. So domain of this given function equals, so as we can see from here, it's negative infinity, it's positive infinity. So the answer is domain is negative infinity comma 0 union 0 comma positive infinity. So the answer is negative infinity comma 0 union 0 comma positive infinity. That becomes the domain of this given function negative 2 over x. All right, so whenever you have the fraction form, so we always see that the denominator is not equal to 0. From there, you can get the domain of the given function. Let's take the next example question and find the domain of that as well. Let's see, the function is f of x. F of x equals, say the function is 2x minus 1 divided by x squared plus 4x. So the question is, what is the domain of this function? Again, you can see that this is also in the form of a fraction. Again, we look at the denominator. So this should not be 0, right? So now we take that. So x squared plus 4x should not be equal to 0. Now from here, I can take x as a common. So if I take x as common, we are left with x plus 4, x times x plus 4 not equal to 0. So the product not equal to 0, which means either x not equal to 0 or x plus 4 not equal to 0. So when x plus 4 not equal to 0, we can say x not equal to negative 4, right? So we got two conditions here. X not equal to 0 is the first condition, and then x not equal to negative 4 is the second condition. Now, let's draw the number line and locate these two numbers. Now let's take a 0 here, and then you have negative 4. Let's take negative 4 on the left side of 0 like this. And now you see that x not equal to 0. So we should not include 0. So we put a open circle on 0. And x not equal to negative 4. So let's put open circle on negative 4. So we are not taking negative 4 and 0, except that we take all other numbers. Okay, so which means, so on the left side we have negative infinity and here it's positive infinity. So what is the domain of the given function? So let's write down the domain. So domain of the given function equals, as you can see, it starts from negative infinity to -4, right? And then union. So -4, comma 0, union. Then you take again 0 to the positive infinity. So this is the domain of the given function. So -infinity, comma -4, union -4, comma 0, union 0, comma infinity. Which means except these two numbers, -4 and 0, all other numbers become the inputs of the given function to x minus 1 over x squared plus 4x. All right. Let's take another example. So whenever you see the fraction form, so always look for the denominator, and that should not be equal to 0. From there, we can get the domain of the given function. Now let's take another question. Say the function is of this type, say f of x equals, the question is say square root of x minus 2. So let's find domain of this function. Now whenever we have square roots, to find the domain, remember in the real number system, the square root function often defined to return only the positive square root, which is called the principal square root, right? Square root of, say, square root of 25, we say it's 5, positive 5, right? So we also get plus or minus, but we take this the positive number. Say if it is square root of 49, we say it's 7, which is positive 7. So we always take the principal square root, which is the positive square root, right? So which means now here, the number inside the square root should be a positive number. So x minus 2 should be positive, which means we take this as x minus 2 should be greater than or equal to 0. Why? So if that is positive, we get the positive square root, right? So the number inside square root should be always positive. So x minus 2 should be greater than or equal to 0. Now let's solve for x. Now we can add 2 on both sides of this inequality. So you can cancel out this 2. You get x greater than or equal to 2. So this is the condition. So x should be greater than or equal to 2. Which means what is the domain of the given function? So the domain of this given function would be, as you can see, x should be greater than or equal to 2, which means, so we are including 2, and it should be 2 or greater, right? So 2 and then positive infinity. So that becomes the domain of the given function square root of x minus 2. All right. Now let's take the next example question and see what is the domain of that function. See, the question is f of x is a function defined by square root of, say we have 3x plus 2. Now, what is the domain of this function? Again, to find the domain, always whenever you have square root, so the inside, that should be greater than 0, greater than or equal to 0, right? That should be positive. So we take 3x plus 2 should be greater than or equal to 0. Now we solve for x. In solving for x, the first step is subtract 2 on both sides. So this cancel out. You have 3x should be greater than or equal to -2. And now you can see that we divide by 3 on both sides of the inequality. So 3 cancel out. You get x greater than or equal to -2/3. Okay, so this is x should be greater than or equal to -2/3. Now what is the domain of this given function? So let's write down the domain of the given function. Domain equals, as you can see, x is greater than or equals. So which means we can take -2/3, right? Which is equal and greater than that. So it should be -2/3 and then the positive infinity. So the domain of this given function is -2/3 comma infinity. All right. Now let's see the next question. Now let's solve the next question and find the domain of that. Say the function is f of x equals, say we have cube root of 4 minus x. So what is the domain of this function? So remember, Whenever there is square roots, we always take the inside, whatever is inside should be always a positive. So we should be greater than or equal to 0. And then you solve it. Here, it's a cube root. Now, whenever there is a cube root, so whenever you see the index here is 3, it's an odd number. So whenever the index is odd number 3, 5, 7, 9, and so on, in this case, what is the domain? So the domain of this given function would be set of real numbers. Okay, so it's negative infinity to the positive infinity. That's the domain. Okay, say now the function is even like this. Say for example, f of x is defined as, for example, say if it is fifth root of 4 minus x. So what is the domain? So again, the domain should be the same thing. So domain is negative infinity to the positive infinity. All right, so whenever the index of this radical sign is 3, 5, 7, 9, all the odd numbers, in this case, the domain is set of real numbers. If it is square root, it's different, right? So if it is cube root, fifth root, seventh root, ninth root, and so on, the domain would be set of real numbers. And that's it. Now you know exactly how to find the domain of any function. Remember, whenever you are working with a function, just ask, are there any numbers that could cause problems? If you spot them, you're already ahead of the game. If this video helped you, don't forget to like, subscribe, and hit that bell so you never miss an easy math breakdown. Thanks for watching. See you in the next one.